Soaps are one of the most widely and commonly used products in our everyday life. We use soaps to do a lot of things, from washing our hands to cleaning utensils. And there's a very interesting chemistry behind how soaps are made in industries, as well as behind their mechanism as to how they work. In the early 20s, soaps were created using primary substances such as rainwater, oil, and potash. But as our knowledge of chemistry increased, we got to know that potash was mainly made up of basic substances like potassium and sodium hydroxide. However, in the modern day world, soaps are created by reacting oils, which are a form of triglycerides, with a strong base to produce soap. Chemically, oils are fatty acid esters of glycerol, which means that oils have a fatty acid tail, which is a long chain of hydrocarbons attached to carboxylic acid groups, and this fatty acid tail is connected to a glycerol backbone by an ester bond. An ester bond consists of a carbon atom attached to three other atoms, which includes a double bond with the oxygen atom, a single bond with another oxygen atom, and a single bond with a carbon atom. Now, in order to make soap, we need some oils. So over here, I have a mixture of vegetable and coconut oil. We have sodium hydroxide as a strong base and some water. We also need a magnetic stirrer for strong stirring. We start out by dissolving our sodium hydroxide in approximately 40 milliliters of distilled water. Then we turn on the magnetic stirrer and allow the solution to completely get dissolved. After making the sodium hydroxide solution, we take a large beaker and add a mixture of oils into it. Then further we add the sodium hydroxide solution and start the chemical reaction between both of them. You can see how the moment I add the sodium hydroxide solution, the entire solution turns cloudy. And that is because sodium hydroxide is a surfactant and it emulsifies the oil to produce soap. Now we turn on the magnetic stirrer and allow everything to completely get dissolved and reacted. So this is what is happening in the reaction. The oil, which is a form of triglyceride, is reacting with the sodium hydroxide to produce glycerol as well as the sodium salt of the fatty acid molecule. And it is this sodium salt of the fatty acid molecule which is soap itself. The sodium hydroxide causes a base hydrolysis of the fatty acid ester of glycerol to produce soap. In detailed terms, what's happening is that the hydroxide negative electrophile from the sodium hydroxide attacks the carbonyl group in the ester bond of the triglyceride. This causes the double bond or the carbonyl group to break, and the double bond converts into a single bond. The hydroxide anion then gets attached to the carbon in the ester group with a single bond. Now, the single bonded oxygen is unstable and it wants to form a double bond. Therefore, in order to form a double bond, the oxygen moves from its place. This movement causes the glycerol backbone to get detached from the fatty acid tail. This detachment causes the carbon oxygen single bond in the glycerol backbone to get detached from the fatty acid tail. The acidic hydrogen from the hydroxyl group then gets transferred to the oxygen in the glycerol backbone to form glycerol as well as fatty acid anion. The fatty acid anion then reacts with the sodium cation from the sodium hydroxide to produce sodium salt of fatty acid molecules, thus forming soap. Now, different soaps are made by using different oils. And these different oils have different lengths of the fatty acid chain. So the fatty acid molecules are different, have different lengths in different types of oils. And depending upon the length of the fatty acid chain, we get soaps with different properties. For example, those soaps which are made up of oils having long chains of fatty acid molecules tend to be much more non-polar and much less soluble in water. On the other hand, those soaps which are made up of oils having a much more shorter fatty acid molecules tend to be much more water soluble. When soaps are dissolved in water, they form a structure known as a micelle structure. This structure has an ionic end which is polar and it is hydrophilic, which means it loves water, and other end which is made up of long chains of fatty acid molecules which is hydrophobic, which means it repels water. And this is what makes a micelle structure. And this structure helps to clear impurities as well as other bacteria. The way a soap functions is that any dirt is in form of different oils and grease which are non-polar molecules. These non-polar molecules tend to be shifted in the micelle structure at the center of the micelle structure, which is made up of non-polar substances which are fatty acid molecules. And since the ionic end is dissolved in the water, so therefore the soap actually takes all the dirt and keeps it at the center and thus washes with the water. Now, soap making takes a lot of time. In fact, its curing period is literally 30 days. Therefore, I will show you my end soap result in a future video. Thanks for watching.